Hello, I'm Lee. In this video, I'm going to show you the data file we programmed, and we're going to use this data file throughout the term. So let's take a look at the header file that defines the data class. The two sections, the private data member and the public interface. So we are trying to model three attributes: name, PCC ID, and GPA here. GPA is a primitive data type, so it's not very interesting. Now let's take a look at name and PCC ID. I'm using a C string to model it, and it's a dynamic C string. So notice at this moment, those two are just pointers to character array. So there's no character array allocated yet. Now let's take a look at the public interface. We have three constructors. The first one is a default constructor, which means it will get invoked when an object is created and the client didn't give you any information for the parameter list. So this constructor will get invoked. And the second one, when they create a data object, they give you the name and the PCC ID. You're supposed to initialize the data member name and PCC ID with this passed in information. And the third constructor is called a copy constructor. So copy constructor will get invoked when the client create one object with another object. And also copy constructor get invoked by the compiler sometimes. For example, pass by value. When you pass a data object by value, a copy of that object needs to be created, and the compiler will invoke the copy constructor for us. If we don't define our own copy constructor, the compiler will provide a default one, which does a field by field copy, which is only copying the pointers. That's what we call the shallow copy. We will take a look at the copy constructor later. And now we also see this Destructor here. So because name and PCC ID, we need to allocate those two character array at runtime. That means later on when the object dies, the Destructor should clean up that memory. So the Destructor gets invoked when the object dies. The lifetime is over. Alright, now let's take a look at the three access function here: get name, get PCC ID, and get GPA. Here, get GPA is straightforward. We just return the GPA through return type because it's a primitive data type, and we can just do that. And get name and get PCC ID, we're trying to return name and PCC ID, the character arrays. Usually, we don't return anything complicated through return type because this return type sometimes we want to reserve it for a flag for if I'm successful or not. You can use a small integer to indicate if the operation is successful or not. So in order to return a copy of name and PCC ID, we do it through the parameter. So the client is going to pass in a placeholder, then your get name is going to return that name through this parameter. We will take a look at the implementation later. And so here, there's something called the constant member function. And here we have constant parameter. So those two constant, they mean something different. This constant means the constructor in this function, it's not going to modify name. And the same case here, it's not going to modify PCC ID. And let's take a look at another constant parameter here. We have constant char star. That means set name, it isn't supposed to modify this parameter. So that's constant char. And you see, get name, this one we don't have constant because we're going to modify this parameter. We're going to return the name through this parameter. That's why it doesn't have constant. So this is constant parameter, which means the function's not supposed to modify that parameter. Now let's take a look at the constant function. constant member function means get name and get PCC ID. They're not supposed to modify the state of the object. So that's a promise of get name and get PCC ID makes to the compiler. Those two functions are not supposed to modify the object state. Now we have set name, set PCC ID, and set GPA for mutator functions. And we have operator overloading here. We're going to talk about operator overloading in the next part of the video. So first I want to do a demo about this constant, why they're necessary. Why do you have to point out get name, get PCC ID, the constant member function? So let's take a look at the driver here. I have student 1. So you see the default constructor get invoked for student 1, and I have student 2. The second constructor get invoked for student 2. And I have a display function. This display function takes a student object we pass by reference, and the display isn't supposed to modify a student, so we put constant there. So we pass in student 2. Now let's take a look. In this display function, I simply display the GPA. In order to display GPA, I have to ask a student, say, what's your GPA? Get GPA. We cannot access GPA directly because that's private data member. We have to go through the public interface. So this looks like a very innocent client here. So it will build. It's currently building now. It takes a while. And we succeed in building. But now I want to modify one little thing. What if I did get GPA here. What if I invoke GPA in that function? I get rid of this constant. If I get rid of this constant, that means get GPA isn't a constant member function. After you do this, you have to do the same thing in the implementation file. If we get rid of get GPA here, you see, otherwise it doesn't know about it because we don't have constant now. They don't match. The implementation file and the declaration file, the .h and .cpp file, they have to match with each other. So if I remove the constant in the header file, I have to remove constant here. So now let's come back to our client. I didn't change anything about the client. The only change I did is to make get GPA non-constant member function. Now if I go ahead and build, and I got error here. So you see, this is the error message. It says cannot convert this pointer from constant data to data. Let's take a look. You see, we declare a student as constant pass by reference, which means display isn't supposed to modify a student object. Then in this function, you're trying to invoke get GPA. How does the compiler know get GPA won't modify a student object? So that's where we have to put in constant here. If we declare get GPA is a constant member function, remember to change it here as well. If we do it this way, then you see the compiler is happy now. It won't complain about it because get GPA is a constant member function, which means it won't modify a student. So that's just a demo to show you why you should make those access function constant because you want to do your client a favor by declaring them to be constant so that your client code can compile with no trouble then. Alright, and now let's take a look at the implementation file for this data.h. That's data.cpp, and the first thing I want to point out is this syntax. This is called the initializer list. So the equivalent to something like this, the equivalent to this, name equal to no, and PCC ID equal to no, and GPA equal to 0. So if you don't use this initializer list, this has the same effect, but sometimes people prefer you to use the initializer list as this syntax. The reason is for efficiency reason, although in our case there really isn't such an issue. When you're trying to initialize an object data member, there will be difference in performance here, but those are not objects, so actually there's no performance difference here. Now let's take a detailed look at this initializer list syntax. So trying to assign node to name, which we're trying to use a syntax looks like the function invocation. So initialize node to name, initialize node to PCC ID, and give GPA 0. This is called the initializer list. And the one thing I want to point out is when we list it this way, it gives us an impression that name get initialized first, then PCC ID, and then GPA. Actually, it doesn't have to be that case. So the order the initializer get invoked totally depends on the order they listed here. So if I list GPA as the first one, then GPA get initialized first, and name get second, PCC ID get third. It has nothing to do with the order here. So it totally depends on the header file or the ordering in the header file. So that's something you might want to pay attention to. In our case, it doesn't make any difference, but sometimes if you're trying to initialize data member 1 and data member 2 relies on the initial state of data member 1, then you need to pay attention to the order there. So now let's take a look at the second constructor. The second constructor, we first initialize the name, PCC ID, and the GPA. Then we invoke the set name and the set PCC ID. We will look at them later. And now let's take a look at this one, the copy constructor. The copy constructor says, I'll give you an object of data, and you're going to initialize your name, PCC ID, GPA with the state of this object. So the implementation is still very similar. We initialize the name and PCC ID with no, then invoke a set name, set PCC ID, and set GPA. I think it's time for us to take a look at those functions. Let's take a look at set PCC ID or set name. They're very similar. Set GPA isn't very interesting. You just set up GPA. And now let's take a look at the set name here. Set name. So we're trying to copy this name into the object's name. So now we have naming conflicts here. Naming conflict, you see the parameter is called the name, and the data member is called the name as well. If you just say name, like here, if I just say name, that means the parameter, the local variable, not the data member. So in order to differentiate them, we have to say this, remember this is a pointer to the current object, then big arrow name. So that means my data member name. Alright. So first let's resolve that one, how to differentiate the parameter name from the data member name when they have identical names. Alright, now let's take a look at the implementation. I first do a testing, say if this name, that means, oh, remember name is a pointer, so that means if name is pointing to any memory, if name has any character array associated with it, we want to first delete that one. Okay, to avoid memory leak here. So we want to first delete that one, then we allocate just big enough for this passed in name, string length name plus 1, that will be just enough. The plus 1 is for the no terminator. Then we do a string copy. So notice here we get a deep copy for name. We allocate big enough, then we do the copy, and we remember to release the existing memory if there's any. And same thing for set PCC ID here. Now let's take a look at the get name. For get name, I'm simply copying my data member into this placeholder the client is supposed to pass in. Just do the string copy here. Alright, okay, let's take a look at the test function. And okay, before we go, let's take a look at the Destructor. The Destructor simply say if I have a name associated with this pointer, I'm going to release the memory and release the memory for PCC ID because both of them are dynamically allocated memory. And now let's take a look at the test function. And how about I want to show you something. I want to show you the usage of copy constructor. If I change my display function as this one, you know that's bad code because really bad. We never pass objects around pass by value. We always pass by reference. If we don't want to modify it, we're going to pass by reference and put constant there. But pass by value, it's a waste of memory and a waste of CPU cycle. It's less efficient than pass by reference. But still, this is legal C++ code. If the client really want to do this pass by value for a student object, our code shouldn't crash. So I'm going to show you here. Okay, and the experiment will go this way. So I'm going to first copy out this, comment out this copy constructor. So I'm going to comment out this copy constructor. And let's say, so I don't have a copy constructor. It compiles fine. Now if I do start, you see the program crash. So if I press retry to debug the application, let's see. Let's take a look. So I'm going to kill this file and let's take a look at the call stack. So main function invoke the Destructor, which means when the Destructor get invoked, so we are trying to delete something. And let's take a look at where it's in trouble. So when I try to delete name, it's in trouble. And take a look at the name. Name and PCC ID, they all contain some very bad pointer there. So let's take a look at what's going on here. I'm going to stop debugging here. So take a look. We say display, and this one is pass by value. Pass by value means when I invoke display, I'm going to make a copy of student object. So the main this display function, this parameter is a copy of student object. And how will the compiler make a copy of student object? it's going to invoke the copy constructor that we just commented out. It's going to invoke this copy constructor. We just commented out, but it still compiles fine because the compiler provide a default copy constructor for us. The default copy constructor is going to just copy field by field the data members. So what you can imagine here is, let's see, I have an object and this is the ID. In this case it's G30. Okay, that's a dynamic memory. And when the compiler, so this is student 2, let's call it S2 in main function. And now when we invoke display, in display we make a copy of S2 because this display function invoked it. And this is a student, let's call it a student. And when it's trying to make a copy, remember the default constructor, copy constructor, is doing a field by field copy. The PCC ID part is just a pointer, so copy this pointer, this is what's going on. Alright, so we call a student and S2. A student is a shadow copy of S2. They're sharing this student ID and student name. I didn't draw that diagram. Alright, now let's see. When display function's lifetime, when display function is over, so you pop this stack frame off. That means a student object, a student object's lifetime is over. So the destructor for a student object get invoked, which means release this memory. This memory is gone. Okay, then we return to main function. Now student 2's lifetime is over before main return. So student 2's destructor get invoked, and you're trying to delete memory that's not there anymore. That's how it crashes as a destructor. Alright, so now we see essentially the problem is when the compiler try to invoke the default copy constructor to make a copy, it makes a shadow copy. That's not what we want. So that's why here we include our copy constructor. We override this copy constructor this way. We say, how do we make a copy? We say, let's put it back. And we set name. Remember, set name will create a deep copy of that name, and set PCC ID and set GPA. So after we provide this copy constructor, let's take a look at the same test code. Alright, now let's start debugging. And this time it didn't complain, and we don't have memory leak either, because I use a memory leak detection tool here. So now let's see. In our data file, so we took a look at the different constructors, and the copy constructor get invoked when you, let's see, when you either pass by value for this object, or let's see, how about this time I initialize student 3 with student 2, then copy constructor get invoked as well. So I know student 3 will be a deep copy of student 2. There shouldn't be any memory sharing between those two objects. So later on, when they run out of lifetime, when the destructor for the student 2 and student 3 get invoked, there shouldn't be any crashing trouble there. Okay, that's for the constructor and copy constructor, and this is a Destructor to release memory. And we talk about why the get function should be constant member function. And we talk about when you set PCC ID, you need to remember to release the existing memory first before you allocating new memory for the passed in name and passed in PCC ID. In the next part of the video, I'm going to talk about operator overloading. Thank you.